we're not doing another one of those. We're moving on to another bit in the chapter, okay? What we're looking at now is going to be equations that we can make into quadratics. Equations that we can make into quadratics. And again, this does crop up at GCSE, although you may get harder examples in what we're looking at now. So that's the first one. Solve x minus root x equals 20. If you look at that to start with, it does not look like a quadratic equation. There's nothing there squared. There's no just, well, there's an x bit and there's a number, but there's no squared bit. Can anybody tell us what we could do? Yes. Yes, you sort of do, yeah. What I'm going to suggest you do is this. If you let some other letter of your choice, I'm just going to use y, equal the square root of x, that bit there becomes y with a minus sign in front of it. What does x become? Y squared. And I've still got that 20 over there. So if you have a letter and the square root of the letter and a number, if you just let any other letter you like be equal to the square root, you can get the quadratic equation out of it. If I was solving that quadratic equation, let's try and do it the easiest way which is possible, not completing the square, not the formula, just by factorising it. What would we do if we were going to solve that equation there? What would be the first thing to do? Yeah, make it equal 0 by taking 20 off both sides. If we're going to factorise that, the minus sign in front of the number, what does that tell me about what's going to be in my bracket? The minus sign.
Plus and a minus.
Yeah, one's going to be a plus, one's going to be a minus. A single y squared here means there'll be a y at the beginning of both. So I'm looking for two numbers that times together to get 20 and add or take to get 1, because there's one y there. What are those numbers? Times together to get 20, add or take to get 1. 5 and 4. And I wish to end up with a minus 1, so I need a minus 5 and a plus 4. So I factorised it. If I factorise it, that means either the first bracket equals 0 or the second bracket equals 0. Well, if y plus 4 equals 0, that means y equals minus 4. The second bracket equals 0. Y minus 5 equals 0. That means y is equal to 5. But I made y up to help myself out. What's y actually equal to? Yeah, so actually y is the square root of x. So either the square root of x is minus 4 or the square root of x equals 5. Okay. Yep. We normally get two answers to a quadratic, which you've got on the y line, but we made y up to help us, to help ourselves out. We need to replace y with what x is, and that was square root of x. But we don't want to know what the square root of x is. We want to know what x is. What do we do to get from the square root of x to x? We square it. What is negative 4 squared? What is 5 squared? So there are your answers to that question. Okay? So it didn't look like a quadratic equation to start with, but we got it to become one. Okay? Right, we're going to look at another one. Same sort of thing. Might not look like one to start with, but it becomes one. We are going to have a go at solving x to the power of 8 minus 2x to the power of 4 plus 17 equals 0. It does not look like a quadratic. There's no squared bit in it anywhere. Without saying exactly what to do, some of you may have spotted it, what's the thing to sort of spot here? That's almost like a thing to look out for. Yeah? Okay. Can anybody spot something that suggests why this will become what we want.
Is that because they're both x to a power?
They're both x to a power. And the important thing, compare that power and that power. What can you tell me about this power compared with this one? It's double, it's twice as big. Yeah, it's double, it's twice as big. So, the power that is not, the power that has been doubled is x to the power of 4. So, let our y be equal to x to the power of 4. So, x to the power of 8 is x to the power of 4 squared. So yeah, the x to the power of 8 is y squared. The x to the power of 4 is y plus 17 equals 0. There's a quadratic, and you just go away and solve it. We're not going to bother finishing it off. That's nothing new. Okay, but that's the sort of thing to look out for. Okay, things that don't look like quadratics to start with, but actually are quadratics. So, there's another thing we need to look at, and that's solving quadratic equations involving, solving simultaneous equations involving quadratics. Okay, and that's our next port of call. Solving simultaneous equations, if I can spell that correctly. Simultaneous equations involving quadratics. Is everybody happy if I get rid of the last example by pushing it up the board? Okay. So, let's have a look at an example here then. If we solve a pair of simultaneous equations, 5x plus y equals 17, which pairs up with 5x squared plus y squared equals 49. There is our pair of simultaneous equations. That's like the end of the question. I would always recommend, anytime you solve simultaneous equations, to label one of them number 1, one of them number 2. It helps you explain to the examiner what you are going to do. Now, there are two methods you would have done at GCSE of solving simultaneous equations. One's called elimination, which is where you try and get the same numbers in front of the x's or the y's and then take them away or add them so they disappear. What's the other method called? Substitution. Okay, and that's the way we're going to do it here. We need to use the method of substitution. If this is a bit rusty to you and you want to go away and look at this in a GCSE book and then come back to this later on, okay, do that. So the method of substitution. Can anybody remind us, what do we do first then in the method of substitution? Tristan.
Like figure out what x or y would equal by rearranging one of the equations.
Okay, you rearrange it until you get one of the equations is either x equals or y equals. Which is the easiest equation for us to do that with? Number 1. So we will rearrange equation number 1 so it is y equals, well, y will equal what then if we rearrange that? 17 minus 5x. Okay. Now we have rearranged that. It's called substitution. That is the next step. So we sub that into the other equation. So we substitute that into equation number 2, which means every time in equation 2 I see a y, I will write 17 minus 5x instead. So I will get 5x squared plus 17 minus 5x, all squared, equals 49. We all happy up to this point? So, what am I going to have to do next? Yeah, multiply that out, okay? I'm going to do that in a grid. Who knows straight off 17 squared? Too slow, 289. Okay. And yes, I did just look at a bit of paper and read that off. Okay. Can you do 17 times by 5 for us, though?
That is 105, I think.
How did he do it so quickly? Is it?
No, 85.
85. Yeah. So, Over here, minus 85x. Over here, minus 85x. You can reclaim your glory spot by getting this bottom one here right.
25x squared.
Yeah. Okay. So that bit is giving us 25x squared. If we start with the x squared bit, which we normally do. The minus 85x minus another 85x will give us minus 170x. And I've got a positive 289. So, what I'm putting in a green rectangle there now gets replaced with what's in that green rectangle there. Okay, so my equation number 2 becomes 5x squared plus that green rectangle equals 49. Okay, what are we gonna do now? Yeah, we will make it equal 0 by taking the 49 off, and we'll try and combine as much as we can. Like 5x squared plus 25x squared is 30x squared. We've only got the one bit of x's, the minus 170x. If we take 49 off 289, we get 240. That equals 0. Something nice about those numbers. Yeah, all divisible by 10. Let's divide everything by 10. That includes the right-hand side as well. What do I get when I divide my right-hand side by 10? 0, okay? So I get a much easier, nicer looking quadratic. What's the favoured method of solving quadratics? Factorizing if we can. Okay? A 3x squared. What's the only way that I could have got a 3x squared? 3x and an x. The positive sign at the end tells me both signs are the same as that sign there. So I can put that in. I need two numbers that multiply together to get 24, and when I triple one of them and combine it with the other, I will get 17. I have a hand up already. Oh, sorry. Yes, sorry. I need two numbers that when I multiply together to get 24, I triple one of them. Which one are you tripling?
3.
Triple 3, so that's got to go in here, away from that 3. And the other number will be?
8.
Okay, let's just see if that works. I will get a 3x squared there, a negative 8x there, a negative 9x there. Negative 8 minus 9 is minus 17, that works. Times those two together, I get plus 24. He was correct. Okay. Sometimes it will take you a bit of time and working out to get there. If it takes you a bit too long and you can't be bothered by it, use the formula straight away if you want to. Okay, rather than get fed up in an angry mood. Okay, so going from here, that means either the first bracket equals 0 or the second bracket equals 0. Second bracket is nice and easy. That will mean x equals 3. First bracket, if I take that 8 to the other side and then divide by 3, I now have two values for x. This is not the end of the question. What do I now need to do? I'm going to go with somebody who hasn't got their hand up at all yet, please. Somebody from the back row. What am I going to be doing next? Emma.
Put it back into the first equation.
To find
The value of
the value of y, and it'll be a different one for each. What I need to do now is substitute that one there into equation 1. Sub into equation 1. Equation 1 was 5x plus y equals 17. Or actually I had another version which was easier to use actually. Y is 17 minus 5x. I'll use that version there. That's going to be more helpful for what I want here. So y will equal 17 minus 5 lots of 8 thirds. Can our human calculator work out that for us?
What's that?
17 take away 5, 8 thirds. That's 40 over 3, as somebody said, yes.
11 over 3.
11 over 3 is the correct answer. 11 over 3 is more commonly known as 3 2/3. We need to do exactly the same thing over here with this one. We're going to substitute this also into y equals 17 minus 5x. I'm going to have to zoom out a bit here. Okay, substitute that 3 into this one as well. We'll get y equals 17 minus 5 lots of 3. Hey, that one's a lot easier. What do we get for that one? Y is 2. Right, now, you need to make sure that this x number sticks with this y number. That x number sticks with that y number. They are not interchangeable. So our final answer, you can either give it as a coordinate pair. The first one was 8/3, 3 2/3. And the second one was 3, 2. Or you could literally write out x equals 8/3 and y equals 3 2/3, or the other possibility, x equals 3 and y equals 2. Okay? Right. We have covered, by my handwriting, 9 sheets of A4 paper today. There has been an awful lot there. We've got 5 minutes left. No, it goes to 1:45. Definitely goes to 1:45. So, folks, if I can just go for a sort of roadmap off from here, what's going to happen? Monday, you've got a test on surds. The lesson after that, I've got prepared, and I'll issue them to you next lesson, is I've got, I think, 7 exam questions on this topic, which we will go through together and produce some model answers. Those questions have come from exactly the same source as your assessed homework questions and your eventual test on this chapter. They're all the same standard, all from the same place. So if you get those 7 model answers done, that'll be really helpful. You have at the moment an assessed homework on Firefly due in next month on this chapter. Remember what I said before, people need to do the assessed homeworks or they get letters home and get thrown off the course. People who want to get good grades will also be doing all the miscellaneous exercise questions on this chapter as well. Yes, that's a heck of a lot of work. End of video.